had a request to do a component for a knife blade, but the interesting thing with this is we have to take a CAD file. From that CAD file, we not only need to get the profile, but we also need to be able to look for a company logo, as well as get true position on a nail mark. So first thing we're going to do is actually go into our editor software and pull up that actual CAD file. So here's the CAD file. Center that in our virtual stage and hit next. I'm going to need to remove this portion of the nail file, as the system won't be able to understand that, but from here I can then fill in everything to give it a virtualized part. Hit next. It doesn't have any dimensions in it, that's fine, and I do not want to create any element tools. I want to do all those myself. Hit complete. Okay, and here's our CAD file. So first things first, let's put in an actual coordinate setting. So we're going to do force show all so we can actually see the CAD elements themselves. Virtual figures, intersection between here and here. The company told me that this is what they want to use as their main reference through the intersection of this location, but using this as the clocking edge. So line and point, again, show all elements. Main line here, point there. Reverse these so that X and Y are in the top right coordinates. Doesn't matter what you want to do as long as you remember where they end up. I always, just for the sake of my own sanity, put them in the top right hand corner. Now we have all of that. Let's now drop in the profile. So the profile is a little interesting. There's a 3/1000ths tolerance on the profile. So we're going to actually put in, well, let's change this over to inch first. All right, now we're going to go into our profiles. Drop in our profile inspection and make sure we grab everything. Beautiful. And put in 0.006 because we're going to use a bilateral tolerance as opposed to the unilateral tolerance that I was given. Now, this hole has its own set of tolerances. So I'm going to double click on this portion, come down to my masking, start masks, and drop in a circle. Shrink this circle down so it's going to be the size of the hole that we do not want to include in the profile. And simply select that. From here, hit apply. The system's going to grab the entire profile, but it's going to ignore that circle. Okay, great. So now since we're working off the CAD part, they do want to get true position for this circle. So we're going to drop in a circle. Hit apply. And it's going to be from the origin points to the circle here. So what I want to find out is, what is that value? So I'm going to circle here to that origin. Look at it horizontal, so we're going to look on the x-axis. That is 1.66. And do it again. And this time we're going to go vertical, so we're going to go along the y-axis, and that is 1.73. Now, I'm not actually entering these in because I don't want to use the CAD coordinate system. I need to use the real coordinate system in order to set this up, which I can't do just yet since we're not working with a real part yet. The second thing that I want to do is that nail groove. So I'm going to show all elements again so that I can see those arcs, and the best way to get position on two radiuses is to simply grab the intersections on both sides of it. So I've grabbed intersections for both sides. Again, same as we did with the circle before, it's going to be point to point, so the point or the intersection of the point here. Do that horizontal along the X. And that's going to give me a 1.260. And if I check it in the vertical, that's going to give me 0.175. Okay, again, point to point between here and here, horizontally. Again, this could also be done in CAD as opposed to doing it in the IMS software. Either way will work. X of 2.037 and a Y of 0.071. It's really just a matter of learning from that base coordinate system where are those points that we need. All right, now that we're done with those, we're going to erase those. We'll come back into those later. The second thing I want to do is drop in this search box. So under Insert, I'm going to insert a marker of a square. Come down here so that it locks on to the CAD model. and expand this out so it locks onto the CAD again. And we'll leave it red. I'm also going to put in a little arrow here so everybody knows exactly where they're supposed to be looking. And now I'm going to put in a comment. So we can let the operators know, okay, there needs to be a visual check. Alright, so we're going to tell them to take a quick look, confirm that the part does in fact have its logo in here. Obviously we can't see the logo just yet, that'll come in a little bit later. Hit OK, gives us a chance to move this box around, so let's throw it up here in the top right hand corner where nobody can miss it. Okay, at this point we are done, so we're going to save this program, hit OK. No, we do not want to register at this point, we don't have the ability to, and I'm going to send this over the network to my IM. So this is the IP address that was given to my IM. And we are going to save this program as the part number, which is 54BLDA06. Save. And leave here. Okay, so now we're done with it on the CAD side. So I'm going to minimize that. And I'm going to bring up screen capture software that I have. So now we're actually looking at the IM itself. So I'm going to come into measurement settings, and you're now looking at a live video. First things first, get the part focused. So hit my focus meter, choose an edge, and make sure that we get that to the right focal height. Alright, beautiful. Second thing, drop in those coordinate settings. We want to drop in the same coordinate settings as before. Now the first thing I can instantly tell is that this edge is far from as repeatable as I'd like it to be. So we're going to run into some issues with that. Anytime you use a datum structure, you need to make sure that it's a very, very repeatable edge. We're going to use here and then the intersection, so there's that point, and drop in the coordinate settings. So we're going to do the exact same thing we did on the CAD file, X and Y, and notice my X's and Y are in the top right hand corner. Those need to be the same. From here, edit, position adjustment, overlap the CAD data, load the file. So let's go find that file. Here it is. Hit open, and it drops it in place. Nope. And as I predicted, so because that intersection is off, the CAD model doesn't match up perfectly to the part itself. This portion will, because that's what it was told to lock to. But up here, we've got some adjusting to do. So position, adjustment, manual move. And let's rotate this a little bit. Try to get that to lock on a little better. And move this down. Move this up a tiny bit. Program's only going to be as good as your base coordinates are. So the worse off your coordinate system, the worse off your profile. Alright, so we're matched up. Attach this. Okay, and you can see that back here where we set up the base coordinates, everything is great. The further we get out to here, we're starting to get some change. We even have some debris on there. Oop, another piece of it over here too. Okay. Let us now turn on the lights. Turn on the lights, hit my light bulb, hit all, bring this backlight down, bring the surface lights up, zoom in on the nail groove, and we're going to draw in the actual arcs now for that nail groove. So I'm going to go to Element Arc, draw this in here, and select dark to bright. So anytime you're going to do a top surface lighting, you have to select the edge type. So in this case, the pink arrow is going up, so we're doing dark into bright. And again, down here, notice it's kept dark to bright. Virtual figures, intersection, grab those theoretical intersection points. So now we have the true position for that guy. Awesome. We also want to get rid of the old coordinate system because we now want to use a real coordinate system as opposed to the fake one that comes in from CAD. I'm going to turn the lights off. Always use backlights when you can. And in this case I can, so I'm definitely going to. Drop those in. Let it do its lighting. You notice here the logo. So looking good so far. Virtual figures, intersection, here and here. And actually, just to show you what I'm doing, if you right-click, you can select line 3. Right-click, you can select line 2, which are the 2 lines I just put in. Let's put in those coordinate systems again. Right-click, line 2, going through here, X and Y, to the top right. Awesome. Now it's time to put in some of those true positions. So circle to point, because I have the real coordinate system right now, on the horizontal. So the values that we got from the CAD was that this was actually 166, and they have a tolerance of 3. Do it again, this orientation. Along the Y, this was 173, again 0.003. That one's good. Okay, next up, point to point, again between the reference, over here, horizontal so that we get it in the X. On the CAD file, that was 1.260. And this one has a 0.02 for its tolerance. So that one's good. Do it vertically on the Y. Y for that one was 0.175. That one's awesome. Here, that was 0.071. And do it one last time, horizontal, and that should be 2.037. So those are all decently well. This one's showing up just a little bit too far back on the part. Last stop, register the pattern. We're going to select this back portion. Accuracy priority, select register. Yes, that works. Hit OK. Save the program. And let's give it a run. So we're going to come into our multi-measurement mode. Hit the measure button. Lights are going to turn on. Going to capture everything there. Lights are then going to turn off, capture the profile. It's then going to bring that lit image back up again so that we can do our visual check. Here it is. Please confirm that the company logo falls within the search box. I can zoom in. Yes, it does. Position, 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 and our profile analysis. That's it. Part is all set, ready to go. If you have any questions, please feel free to ask.